Hello friends, welcome back to class 11 mathematics. So if you remember last class we did studied about relations, isn't it? So today we are going to study, and then we did an exercise also. So today what we're going to do here is we're going to learn lots of things of functions. So I want you to be with me, bring out your pen and paper, start writing down. I'm going to give you many types of functions. We're going to study functions completely. I'm going to make sure that it's going to become very easy for you, because there's always a lot of confusion with functions with students. Functions, relations, domain, range, so many confusions. Let's try to remove that confusion today. Okay, so today we're going to study about functions. I have written down that definition for you. You can kindly pause the video and write it down. So today what we're going to do is we're going to be studying about functions. We're going to be studying about different kinds of functions, and then of course we're also going to clear the concept about domain and range about a function. So this topic generally will be useful not only for 11 but as well as 12 also. So I hope you've written down. So what is a function? So what was before that? What was a relation? Relation was a rule or a set which has to be a subset of the set A cross B if the relation is defined from the set A to B. Now when we move to function is a relation now. So it comes like this. Okay, let's first go through this. So function, let A and B be two non-empty sets. Fine, sets again. Then a function is also a set. Okay, then a relation. A relation is a set again. So this is a special type of a relation. So that means a function actually denoted by f is a special type of a relation again. Okay, what's special we're going to study. So it's a relation f from A to B is called a relation. If, so I'm going to wrap this off. It's called a relation if every element in the set A, that is the first set, has a unique. In mathematics, what do we mean by unique? Not only mathematics, general meaning of unique. Unique means one. Special. Unique means just one. So if every element in the first set has a unique image in the second set, and then only we write a function is defined from A to B. So that is actually the definition of a function. So if the ordered pair belongs to the set F, which is a function, then we write as usual the first element corresponds to the second element, that is f of A is equal to f of B. That we have already studied in relations also, same concept only that function there will be some more strict rules to follow, that's all. So here of course B, this second element is called the image of the first element, and got that, no? B is called the image of the first element, and A is called the pre-image of the second element, second ordered element. So if then in that case, if f is a function from A to B, the slight change will be there with now domain and range and codomain. Domain remains the same for relation also. Domain of function f will be the first set A. Same for a relation also. Range only is going to be different, because range of f will be a subset of the second set, whereas the range for relation was the set of second ordered elements, almost the same only. Range of f will be equal to a subset of B. Okay, so fine, all these things written. Let's just rub this off. That is a mathematical part. Let's not talk about in general. What is a function? How is it different from a relation? I'll give you a very good example. Okay, let us consider these functions to be like two people. Now, two people maybe of the same family. Two people, two persons, maybe two brothers, or the same family. So functions as well as relations are brothers. Maybe function is the younger brother. Understood? Now, considering these two people as the relation and function as two persons, relation is that older brother who is like more open towards people. He likes making friends with everyone. He loves everyone, and then he just goes around mingling with everyone. That is relation. Whereas function is kind of, an introvert. He doesn't want to mingle with people too much. He just has few select friends, maybe just one or two select friends. Unlike relations, who is more of an extrovert, he just goes around people with optimistic, just goes around people, meeting people, makes lots of friends, whereas his younger brother, who is a function, is kind of reserved. He doesn't want to mingle with everyone. With that concept, if we come back to understanding the concept of functions, I think that's going to be clear. So let's keep that too in mind, okay? Relations and functions. Two brothers of the same family, relations more open, lots of friends. Functions a little bit more reserved, doesn't like to mingle with everyone. That is the difference between a relation and a function. Mathematically, let's see the difference. So that means all this comes from sets only. And then of course we have this Cartesian product of sets. From Cartesian product of sets we have relations. These are all like special filtering and filtering relations. And then again within relations we have functions. So if you go for a Venn diagram, it's something like this. If you go for a Venn diagram, this is the bigger set. So that's like A cross B. Within this set, we have relations. And within the set of relations, we have functions. So that will make the notation about, that will give us an idea about what are sets, what are Cartesian product of sets, what is a relation, what is a function. So with all this, we at least come to one conclusion that all these are what? Just sets only, special type of sets. Fine. Now let's go back to learning what is a function. So let's move back with one example, that is, okay, if we just consider a set A, 1, 2, 3, 4. Then a set B, 1, 4, 9, 16, 25. And then of course I am going to define relation. Let's just assume a relation, okay, let us just assume a relation which is made up by the ordered pair x, y, such that x comes from the set A, y comes from the set B, that is the relation is defined from A to B, and y is x squared. So let's form this ordered pair. So y is x squared. So if x is 1, y will be 1 squared, that is 1. If from this 1, 2, 3, 4, because x should all come from the first set. So if x is 2, y will be 2 squared, 4. If x is 3, y will be 3 squared, 9. And if x is 4, y will be 4 squared, that is 16. But that's all because in the first set we have only 1, 2, 3, 4. Done. Now you see, when you go for Cartesian product of sets, we get many elements, isn't it? So forget about that. So now here you will see that every element in the set A, every element in the set A corresponds to just one element. That means if you go for Venn diagram, Venn diagram, so it's like 1, 2, 3, 4. So we have the second set 1, 4, 9, 16, 25. So when that happens, 1 corresponds to 1 only, 2 corresponds to only 4, 3 corresponds to only 9, 4 corresponds to only 16. And that is exactly what was the definition of a function. A function is a relation defined from A to B such that every element in the first set A, if the function is defined from A to B, every element in the first set should have a unique image in the set B, and that is fulfilled. One has only one image, so this 1 is the image of this element, 4 is the image, so this consists of the set of image. Okay, so 1 is the image of 1, 4 is the image of 2, 9 is the image of 3, 16 is the image of 4, and this set contains the pre-image. There is 1 is the pre-image of 1, 2 is the pre-image to image backwards that's why it's called pre-image. So that is the concept of functions. Now what was the difference with relations? That's why relations to it didn't really matter. Like 1 can be associated with 1 can be associated with 2. You can check out some examples from the last videos or last exercises and all. 1 could be related with 6, like again 2, 4, again 2, 6. With a different rule, of course. That's why it's a this rule only corresponds to functions. You change the rule, you might get a relation. So here you will see 1 doesn't have a unique, it has an image, but doesn't have a unique image, because 1 has image 1, 1 has another image 4, so it's not unique. So this was a relation, and this was a function. So now you understand Did you understand the difference between the function and the relation about the two brothers? This is the elder brother who likes to mingle with, many people, very open. This is the younger brother who is a little bit more reserved. He has like just one friend. Just doesn't want to mingle with everyone. Just one for one. Just specific. So 1, 1, 2, 2. That's the difference. So whenever you get confused, I think this story I think will remove your confusion. Elder brother, smaller brother, more open. One is more reserved. So that's what is a function. So what is a function? A function is a special type of a relation in which every element should have only a unique, in every element should have a unique image bus. Now, what we will do is we will try to, let's try to do with some Venn diagrams. Okay, let's try to recognize some arrow diagrams. So I'll give you some diagrams. You try to recognize. This will be like an activity for you. So it's going from this direction to this direction. The other function 1, 2, 3, A, B. So you can kindly note it down, and then maybe this will be something like an activity for you. Okay. This is my second diagram. And okay, another diagram. Like, if you can answer all these questions correctly, then I'm very sure the whole concept of functions will be easily, that means you have understood the whole concept of functions. Then again another diagram. 1, 2, 3, A, B. Fine. This will be the fourth figure, and maybe one more. From this range of 1, 2, A, B, C, this and this and this and this. So okay, here are 5 figures. So here are 5 figures. You can pause the video and then you can just kindly go through it properly and tell me which are the images which corresponds to functions. Function de ekta element khale ekta image thakibo lage. One element should have only one image. But again, there are two conditions. Every element should have an image. Sob element to first set laga. Image ekta thakibo lage, and that image should be again unique. So every element should have a unique image. Simple. So look at the figures and see, and you can tick for yourself which are functions. Let's get back to the answer now and see how many could you get correct. First one, absolutely a function, because every element in the first set has an image that is also one to one only, just unique image. So first one is a function. Second one, what do you say? Second one is also a function, because first thing, you have to check two things. Does every element have a function? Yes or no? Yes, every element has an image. 1 has an image A, 2 has an image B, 3 has an image B. Fine. And they all have a unique image. See, that's what I mean. Don't get confused here. Get confused in the khali, okay? One laga image, one has an image only A. What about 2? Some of you may be confused. No, sir, there are 2 maps going from here. Read the definition properly. Every element in the set A should have a unique image. Nobody talked about pre-image. We are talking about only the image. 2B, 3B. So, to clear your confusion more again, 2 has an image B. Does 2 have another image? No, isn't it? 2 doesn't have another image again. 2 has only one image. What about 3? 3 has an image B. 3 doesn't have another image. So it fulfills the definition. No, every element should have a unique image. Nobody talked about pre-image. They can have 2, 3 pre-image. B has 2 pre-images, 2 and 3. Let it be. Who cares? We do not talk about that. We're just talking about the image only. So that should be your motive. Every element in the first set should have a unique image. Nobody talked about pre-image, so don't think about pre-image at all. So the second one is also a function. What about the third one? Here comes the problem. Slight difference. Third one has an image A. Now you look here. This is what I mean. 2 has an image B. 2 has an image C. So actually like 2 doesn't have a unique image now, isn't it? Because 2 has now like 2 images. 2 has 2 images, B and C. So what happens is this is not a function. What about this one? Here to the first criteria itself is not fulfilled because every element sub element to image eta thakibo lage. But here to just from the first condition, here every element doesn't have an image at all. 3 doesn't have an image at all. So no need to go further. No chance. 3 la the image in I, so that's absolutely not a function. What about this one? First criteria, every element has an image. Yes, 1 and 2, they have an image. Again, I repeat, we are not concerned with what happens with the second set because the function is from A to B. So every element has an image. Does it have a unique image? I think so. 1 has only A, 2 has only B. But C doesn't have a pre-image. Did we talk about pre-image? No. Let it be. So this is also a function. So I think this arrow diagram has cleared the concept for you about functions. So that's how simple it is. Now when we talk of, let's say, domain and range, let me just clear with one more example. So 1, 2, 3, A, B, C, D. So let's say 1A, 2C, let's say 3D. So is this a function? Definitely yes, because every element has a unique image in the set B. That's what is our concern. So what will be our domain? What is going to be our domain? Domain of the function f. Domain of the function f will be the set of the first order elements 1, 2, 3. Definitely this will be the entire set A itself. So that's why there is, from the definition, domain of f, if a function is defined from A to B, then domain of f will always be the set A because every element should have an image. So every element means the domain. Range only may be different because range of f here, if you look, is the range set of the images. So what are the images here that is being formed? A, C and D. A, C and D. That's why from the definition it was written that range of f is going to be a subset. Maybe not a proper subset. Maybe an equal set also is a subset of the set B. Okay. Alright, and then of course codomain, that's alright, codomain not a big issue because codomain is always the second set, that is A, B, C and D. So I hope that I have cleared the concept of functions for you. I actually wanted to do different kinds of functions, but I think we have already spent quite a long time. So definitely in the next video I will be discussing about different types of functions, which is again going to be very, very important as you move onwards. We have signum functions, we have greatest integer functions and many more functions. So fine, that will give me more time in the next video to discuss in a bit more detailed manner about the other kinds of functions, which is going to be very important. So I hope that you have liked this video. The concept of functions is like poof, it's understood now. Definitely I will be making an effort to explain that more again in the next video also. So please, if you have liked this video, do like, subscribe, and then of course share with maximum of your friends. And then study well, stay safe. Until then, I'll see you in the next video. All of you, stay safe. Bye bye.